Hello everyone. So in this class, this is the continuation of previous class. So in the last class, we are discussing the binomial theorem. Okay, we are proving binomial theorem by using principle of mathematical induction. So we have proved the given statement for n is equals to 1. Then we have assumed the statement is true for n is equals to k. After that, we have proved the statement is true for n is equals to k plus 1. So we can see that whenever the statement is true for n is equals to k, so that is p of k is true implies p of k plus 1 is also true. Means whenever statement is true for n is equals to k implies the statement is true for n is equals to k plus 1. So by principle of mathematical induction, what we can conclude? So the statement is true for all natural numbers n. Now we will see some of the special cases of binomial theorem. So we have seen that the expansion of a plus b power n is given by nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square. So on. Last term is ncn a power 0 b power n. Now we will see the first case. Suppose if we take a is equals to x and b is equals to minus y. So then this expansion we can write it as a means x. In place of b we can write minus y. So a plus minus y means x minus y. Our n is equals to nc0. In place of a we have x. So we can write it as x power n plus nc1. A means x. So x power n minus 1. B means minus y plus nc2. A means x power n minus 2 b square. Since b is minus y whole square plus so on. So last term is ncn b. Since b is minus y, so minus y whole power n. So if we simplify, so what we will get here? nc0 x power n. See here, plus into minus becomes minus nc1 x power n minus 1 y. Here minus y whole square. Minus square becomes plus. So plus nc2 x power n minus 2 y square. So on. Last term ncn. So minus y whole power n. So we can write it as minus 1 into y whole power n. So that is same as minus 1 power n into y power n. So this is the expansion of x minus y whole power n. Second one, suppose if we take a is equals to 1 and b is equals to x. So this expansion becomes, so here LHS becomes 1 plus x power n is equals to RHS will be nc0 1 power n. 1 power n means 1 less nc1 1 power n minus 1. So that is also 1. B is nothing but x less nc2 1 power n minus 2, that is 1 b square. Since b is equals to x, b square becomes x square plus so on. Last term is ncn b power n. So that is b is x power n. So the expansion of 1 plus x power n becomes this one, nc0 plus nc1x plus nc2 x square so on ncn x power n. Suppose if I take x is equals to 1. So in this expansion, if I take x is equals to 1, so what I will get? LHS becomes 1 plus 1, that is 2 power n is equals to RHS will be nc0 plus nc1, x value is 1. So into 1 becomes 1. So nc2 into 1 square, that is 1 plus so on. Last term is ncn 1 power n becomes 1. So if you add all the coefficients, so what we'll get? We'll get it as 2 power n. For any index n, if you add the coefficients of the expansion, it will be what? Powers of 2. This we have seen in the Pascal's triangle. Suppose consider if you add the coefficients of a plus b power 4. So a plus b power 4 means if you expand, what will get? 4c0 value is 1. That is 1 into a power 4 less 4c1. 4c1 means 4. What will get? A cube b less 4c2. 4c2 means 4 factorial by 2 factorial into 2 factorial. So that is 6 a square b square. Next 4c3. So that is 4 a b cube plus 4c4. 4c4 value is 1 b power 4. So here index is how much? Index is 4. So n value becomes 4. So if you add all the coefficients, how much? Here 1 plus 4 plus 6 plus 4 plus 1. So that is how much? 5, 10 plus 6, 16. So this is nothing but how much? 16 can be written as 2 power 4. So for any index n, so if you add the coefficients, what we will get? The sum of the coefficients will be power of 2. Third one. Suppose if we take a is equals to 1 and b is equals to minus x. So what we will get here? LHS becomes 1 minus x power n is equals to RHS will be nc0 1 power n becomes 1 less nc1 1 power n minus 1, that is also 1 into b means minus x less nc2 1 power n minus 2, that is 1 b means minus x whole square plus last term is ncn b means minus x power n. So if we simplify, so what we will get? nc0 here minus nc1 x minus x whole square, that is x square. So plus nc2 x square minus plus so on. Last term is ncn minus x power n. So we can write it as minus 1 power n into x power n. So this is the expansion of 1 minus x power n. Suppose if we take x is equals to 1. So if I take x is equals to 1 in this expansion, so what we'll get? LHS 1 minus 1. So 0 power n is 0 is equals to, here what we'll get? NC0 minus x value is 1. So NC1 into 1 plus NC2 into x square. X square means 1 square is 1 minus next term will be NC3 plus so on. Last term is NCn minus 1 power n. So 1 power n is 1. So if you rewrite this one, so what we can write? NC0 plus NC2 plus NC4 so on is equals to, here if you take NC1, NC3, NC5 to LHS, so what we can write? NC1 plus NC3 plus NC5 plus so on. So that we can conclude that for any index n, so sum of the coefficients of odd terms is equals to sum of the coefficients of even terms. So as we have seen in the previous case, suppose if you consider a plus b power 4, so expansion, if you see the expansion, what we'll get? So that is a power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b cube. So this is the expansion of a plus b power 4. If you consider the coefficients at odd terms, so this is first term, this is the third term, so this is the fifth term. If you add these coefficients, so what we'll get? Here coefficient is 1 plus 6 plus 1. So that is equals to sum of the coefficients at odd terms is equals to, see here, these are the second term, this one. So this one is fourth term. If you consider the coefficients, what we'll get? This is 4. Here also coefficient is 4. So 8 is equals to 8. So what we can conclude? For any index n, sum of the coefficients of odd terms is equals to sum of the coefficients of even terms. Now let us solve exercise 8.1. Expand each of the expression in exercise 1 to 5. First question, 1 minus 2x power 5. So solution. So we have seen the expansion for a plus b power n. So that is equals to nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square, so on, ncn b power n. So here if you compare this with the standard expansion, so we can take a is equals to 1 and b is equals to minus 2x. So here a value becomes 1, b value becomes minus 2x and n value becomes, here index is 5. So the expansion of this one, we can write it as 1 minus 2x power 5 is equals to, see here, nc0, n value is 5. So 5c0 a power n. So a value is 1. 1 power 5 plus nc1. Since n is 1, 5c1, 1 power 5 minus 1. So that is 4. B value is minus 2x plus nc2, 5c2 a power n minus 2. So that is 1 cube. See here, powers of a goes on decreases. Here a means 1. 1 power 5, 1 power 4, 1 cube into b powers goes on increases. Minus 2. Here minus 2x power 0, minus 2x power 1, minus 2x square plus 5c 3, 1 square minus 2x cube plus 5c4, 1 minus 2x power 4 plus 5c5 minus 2x power 5. So you have to remember this one. So powers of a goes on decreases by 1, whereas powers of b goes on increases by 1. So if you expand this one, so you should remember this formula NCR. NCR means n factorial by r factorial into n minus r factorial. So 5c0, 5c0 means what we will get? 5 factorial by 0 factorial into 5 minus 0 factorial. So that is 5 factorial by 5 factorial. So 5c0 value becomes 1. Again 1 power 5 means 1. Plus, here if you want, plus into minus becomes minus 5c1. 5c1 value is 5. If you want, you can compute by using this formula by taking n is equals to 5 and r is equals to 1. So if you simplify, you will get the value of 5c1 as 5. So this is 5. 1 power 4 is 1 into 2x plus 5c2. 5c2 means 5 factorial by 2 factorial into 5 minus 2 factorial. If you simplify, what you will get? You will get 10 into minus 2x whole square. If you square, what happens? Minus will becomes plus. 2 square is 4 into x square plus 5c3. So this value is also 10. 1 square is 1 minus 2x whole cube. So minus 2 whole cube becomes minus 8 into x cube plus 5c4. 5c4 value is 5 into minus 2x power 4. So minus 1 power 4 becomes 1. So 2 power 4. 2 power 4 is 16 into x power 4 plus 5c5. 5c5 value is 1. So minus 1 power 5. So that is minus 2 power 5. 2 power 5 is 32 into x power 5. So that is equals to 1 minus 5 2s are 10. So 10x here plus 40x square here minus 80x cube plus 16 5s are 80 x power 4 minus 32 x power 5. So this is the required expansion of 1 minus 2x power 5. Second question, 2 by x minus x by 2 whole power 5. So we have to expand this one, 2 by x minus x by 2 power 5 by using binomial theorem. So we have seen the binomial theorem, that is a plus b power n is equals to nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square, so on. Last term is ncn b power n. So this is the binomial theorem for positive integer. So here if you compare these two, we can take a value as 2 by x. Since we have plus here, so we can take b is equals to minus x by 2 and the value of n value becomes 5, and to find the values nc0, nc1, so on, so we will use the formula, that is combinations. ncr means n factorial by r factorial into n minus r factorial. So the expansion of this one, 2 by x minus x by 2 power 5 is equals to, so what we can write, in place of n we can take 5, so 5c0 a power n, so a value is 2 by x power 5 plus nc1 means 5c1, so next term 2 by x power 4. As I told, powers of a goes on decreases by 1, power of b increases by 1, b means minus x by 2 plus 5c2 into 2 by x cube into minus x by 2 whole square. Next term is 5c3 2 by x square into minus x by 2 whole cube plus 5c4 2 by x into minus x by 2 power 4 plus last term, that is 5c5 minus x by 2 power 5. So we have expanded by using the formula. So powers of a is decreasing by 1, power of b is goes on increases by 1. Now if you simplify this one, the value of 5c0. 5c0 means it is 5 factorial by 0 factorial into 5 minus 0 factorial. So this value becomes 1 into 2 by x whole power 5. So 2 power 5 means 32 by x power 5 plus, or plus into minus becomes minus 5c1. 5c1 value is 5 into, see here, 2 power 4 divided by 2, that is 2 cube. 2 cube becomes 8 divided by x power 4 into x. So what we'll get, x by x power 4, that is x cube. So 5 into 8 divided by x cube. Here 5c2 means 10 into, see here, 2 cube divided by 2 square. 2 cube by 2 square. So 2 square will get cancelled, that is 2. Here minus whole square becomes plus. Here x cube, here x square. So x square we can cancel. So what is remaining, that is x. Here minus 1 whole cube is minus. So plus into minus becomes minus 5c3. 5c3 value is again 10 into, see here, 2 square, here 2 cube. So we can cancel 2 square. So remaining is 2 in the denominator. Here x cube by x square. So x square we can cancel, that is x. Here minus 1 power 4 means plus 5c4. 5c4 value is 5. If not, we can use this formula, 5 factorial by 4 factorial into 5 minus 4 factorial. So if you simplify, you will get the value as 5. Here, so what we will get, 2, here 2 power 4. So 2 will get cancelled. So 2 cube, that is 8. Here x power 4 by x. So that is x cube. Here minus 1 power 5 is minus, plus into minus becomes minus 5c5. 5c5 value is 1. So what we will get here, x power 5 by 2 power 5 is 32. So simplify this one. So if you simplify, 32 by x power 5 minus 40 by x cube plus 20 by x minus 10 by 2, that is 5x plus 5 by 8 x cube minus x power 5 by 32. So this is the expansion of 2 by x minus x by 2 power 5 by using binomial theorem. So other questions are left to the students. They can try the other problems by using the same procedure what we have studied earlier. So next question, using binomial theorem, evaluate the following. First question, sixth one, 96 cube. So here what we are going to do is we are converting this number 96 into sum or difference of two numbers such that whose powers are easier to calculate. So 96 is nearer to 100 and we know that 100 powers are easier to calculate. So 96 cube, 96 means I can write it as 100 minus 4. So since we have cube, so 96 cube can be written as 100 minus 4 cube. Now finding the value of this is same as what? Finding the value of 100 minus 4 cube. So let us find the value of 100 minus 4 cube by using binomial theorem. So binomial theorem for positive integer is given by a plus b power n is equals to nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square, so on ncn b power n. So here a value is 100, b value is minus 4 and n value is 3, and the general formula for the combination, that is NCR is equals to n factorial by r factorial into n minus r factorial. Now let us expand 100 minus 4 whole cube by using binomial theorem. 100 minus 4 whole cube is equals to nc0, here n value is 3, so what we will get 3c0 a power n, a value is 100 power 3 plus next term nc1, so that is 3c1 100 square into b, b means minus 4 plus nc2, that is 3c2 into 100 into b square, b square means minus 4 whole square plus next term is 3c3 minus 4 whole cube. So we have used the binomial theorem. So that is equals to 3c0, the value is 100 cube, 100 cube means we have to put 6 zeros, plus 3c1, here plus into minus means we can write directly minus 3c1, that value is 300 square. 100 square means we will get 4 zeros after 1 into 4. Here minus whole square becomes plus 3c2. The value of 3c2 is 3 into 100, 4 square. 4 square becomes 16. Here 3c3 value is 1 minus 1 whole cube, that is minus 4 cube is 64. So that is equals to minus 4 3s are 12, 16 3s are 48, minus 64. So if you simplify this one, we will get the required answer. So if you want, you can simplify this one. So what we'll get here? Minus that is 6, 3, 7, 4, 8, 8. So the required answer is 8, 8, 4, 7, 3, 6. So like this we can find the value of the quantities like this. We have to convert it into the nearest value, okay, such that we can find the powers of those two numbers easily. So whenever we have 96, 99, 101, 105, we can take the nearest value as 100. Similarly, 990, 995, then we can take the value as 1000. Then we can use the binomial theorem for the expansion. Next one, question number 8, 101 power 4. Here also we are going to express 101 as the sum or difference of two numbers whose powers can be easily calculated. So 101 is nearer to 100. We can find the powers of 100 easily. So 101 we can write it as 100 plus 1 whole power 4. Now we are going to expand this one by using binomial theorem, that is a plus b power n, by taking a is equals to 100, b is equals to 1 and n is equals to 4. So this is the formula to find NCR. Now if we expand 101 power 4, so what we will get here? NC0, that is 4C0, a power 4, a is 100 power 4, plus 4C1 100 cube into b, b means 1, plus 4C2 100 square into 1 square, plus 4C3 100 into 1 cube, plus 4C4 1 power 4. We have used binomial theorem. Powers of a is decreasing by 1, power of b is increasing by 1. If we simplify this one, 4C0 value is 1 into 100 power 4. So 100 power 4 value becomes this is the value of 100 power 4. We have to put 8 zeros after 1, plus 4C1. The value of 4C1 is 4. 4 into 100 cube. 100 cube means what we will get? 6 zeros. Plus 4C2. 4C2 means 4 factorial by 2 factorial into 4 minus 2 factorial. So that is 6. 6 into 100 square. That is 6 into 100 square is 10,000. So what we will get? 60,000, plus 4C3. The value is 4 into 100. So that is 400 plus 4C4. 4C4 value is 1 into 1 power 4 is 1. So if you add all these values, you will get the value of 101 power 4. So if you add, what will you get? So that is 1. Here 1. Next 0. Next 4. After that 0. Next 6. Next 0. 4. So 1 0 4 0 6 0 4 0 1. So this is the required answer. So that is 101 power 4 value is 1040604041. So we will continue in the next class remaining problems. Thank you.